So hello दोस्तों, welcome to Geeks for Geeks. This is Aman Gupta. Today I am here to do post analysis of contest weekly contest 197. So tell me in the comment box how many questions were you able to solve and how many questions you find difficult. Okay, so I think you enjoyed the problem, and now we are moving to our first problem, that is count XOR pairs. So what the problem is saying, let's see. You have given an array of size n containing permutation. Keep the points permutation of numbers from 0 to n minus 1. Let's think, what is this? I have an array in which I have given the numbers from 0 to n minus 1 definitely means no number is repeating. Okay. If suppose my n is 4, if my n is 4, what are the elements of array that are 0, 1, 2 and 3, and it is said that it might be any permutation of that numbers. So our array can be any permutation of 0, 1, 2, 3 for n equals to 4. Now what our task is, your task is to find the number of pairs I comma j. So I need to find I comma j pairs such that arr of I XOR arr of j is equals to their XOR of their index, that is I XOR j. Now it is XOR, it is given that. So, what do you think? The brute force approach can be travel every pair of the I comma j and see if the the XOR of the elements is equals to the XOR of their indexes. Then we can easily increase our count. This is the brute force approach, and brute force approach will take the time of big O of n square. Now we can think about some optimization. How? Let's take this thing. Before moving forward, let me tell you that XOR A is 0, and also A XOR with 0 is equals to A only. These are the two properties. Now, taking this condition that is given in the question, that is ARR of I XOR ARR of J is equals to I XOR J. It is given. Now I need to find some relation between them so that this problem will become easy. How? Can I do one thing? If I want to map ARR of I with I, or I am able to map ARR of J with J, it can it can solve my problem. Let's see how it can be done. If both of side, both of side, can I do one thing? Can I do XOR with ARR of J with I in the both of side? I XOR J XOR ARR of J. Let's see what happened. Now, this ARR of J XOR ARR of J, I've told you that A XOR A is 0. So it will become 0, and anything XORed with 0 will remain same. So I can vanish them, and here in the LHS I can write that ARR of I XOR I. In the RHS, let's see, I will be XORed with I, and A XOR A is 0, and anything XORed with 0 will remain same. So can I write ARR of J with XOR J? So this is my final observation. This is my final observation that what can I say after watching this? That any number XORed with this index should be equal to any other number XORed with its index. So how can we modify this problem? Let's see. Let's see. For 3, let's take this example. 3210. Let's take this example. ARR is given as 3210. I want to XOR every element with its index. So let's write index here. I'm writing IND index 0, 1, 2, and 3. Let's take the XOR. Let's take the XOR of every element. Now our XOR array will become like that. 3 XOR with 0. Let's see. 3 is 1, 1. 0 is 0, 0. What is the XOR? We know that 1, 1. 1, 1 will be the XOR. And what is 1, 1? That is 3 only. That is 3 only. Because 0 XOR with 1 is 1. And if we do XOR of same value 0, 0, 1, 1, it will become 0. So 2 with 1. Let's see 2, 1, 0 is 2. And 0, 1 is 1. XOR is again 1, 1, 3. For 1 and 2, it is similar 3. For 0 and 3, it is again 3. Now, now my problem will change to count every pair of ij. See, now my problem changes to count every pair I comma j for which the values at these indexes are equal. Can I say that? Count every pair I comma j for values at these indexes are equal. At these indices are equal. Can I say that? And here I can see that for 3, I can make this 3 with these 3 pairs. So my answer will be, let's see how many pairs are there. 3 initial pair here. With this 3, I can pair with this 2. So I am adding 2. With this 3, I can make only one pair. So I am adding 1. So final answer will become 6. And this was my expected output also. So I can change my problem to count every pair I comma j for values at their indexes are equal. And we can find this in big O of n. Let's move to the solution. See, this was my question. And I want to return long value. So I have declared a long answer. Along with this, I have find the array size. I have executed an loop. For that, I'm calculating the XOR operation of that value with its index and storing in its value only. After that, I have declared a map to count every pair with the same values. How can I do that? We know that it can be easily be done using map. How? Let's see. Answer plus if I'm storing the value of every element in the map and along with storing, I'm checking if the value is already present, I'm adding it to my answer. And finally, I'm returning my answer. With this, I can easily solve the problem. Let's see. Now, let's execute it. So we are done with the first problem. Let's move to the next problem. So this is our second problem. Let's see what the problem says. Given an array of non-negative integers, ARR, what is the task? The task is to find the max. First of all, the definition of max is given here. That we will see this later. Max of all possible values obtained by taking bitwise or operator every possible subsequence. Let me describe. First of all, we have an array. First of all, we have an array. Then we will find all possible subsequence, all possible subsequence of that array. After that, perform OR operator between every element, perform OR operator, OR operation between the elements of every subsequence. After that, we will get an array of single digits, which is representing the subsequence or operation of subsequence of that array. After that, we will have to find max. Now we will see what is max. Max is defined as the smallest positive element, okay, that is not present in the array. Okay, so with the example, they have given that for 0, 1, 2, 4, the max is 3 because the smallest positive integer that missing in that array is 3. But here in array 1, 2, 3, 0 is missing. That is why the max of this array is 0. Now we understood max. And they also given the definition of subsequence. Subsequence is generated by deleting elements from any position of the array. For example, we know subsequence 235 subsequence can be 3, 5, 3, 2, 2, 5, like that. Okay, no issue with the problem. Let's jump to the brute force approach. If we try to code using brute force approach, what can we do? First of all, we will take this array and generate all possible subsequence and store them in vector of vector. After that, we will perform OR operation between every row because single row will denote one possible subsequence. After that, we will have an array. I will sort them and see what is the minimum or smallest possible element that is not present in the array. This is called max, and we will return that. Do we think the brute force approach is good approach? No. So now we will think about some optimal solution of this problem. Some key observation of this problem. See, here we want to generate all the subsequence. After that, we are performing OR operator. This is the case. And here OR operator will rely on the power of 2. Let me tell you why. Because if I am writing 1, the binary representation of 1 is 0, 1, and the power of 2, 2 raised to the power 1, the representation is 1, 0. For generating 2-bit number, either one of the this bit, least significant bit must be high, either from 1 or from 2. If there is high bit at this place, then this place will become high. Same for this, same for this place, this bit should be high in any of the number, then this bit will be high. So what can I say? If 2 raised to the power 0 and 2 raised to the power 1 number are present, I can generate 0 to 3. Let's take another example and understand what I'm trying to say. See, for 1, that is 2 raised to the power 0. For 2 raised to the power 1, that is 2 only, and take 2 raised to the power 2, that is 4. Write the binary representation of each of them, that is 0, 0, 1, and for 2, it is 0, it is 1, it is 0, and for 4, it is 1, it is 0, it is 0. You can see if 1, 2, and 4 are present, there is all set bit present in every sequence of the number. See, for this place, I have 1. For this place, I have 1. For this place, I have 1 here. So I can generate all the numbers from 0 to 7. For here, what is the least number that can be missing? Max, my max. My max will be 8. My max will be 8. If 1, 2, and 4 is present in my sequence, in my array, if 1, 2 and 4 will be present, then my max will be 8, because the minimum number that I cannot generate is 8, because the fourth bit is not high. The fourth bit is not high for any number. That is how we can observe this problem. The pattern to solve this problem is finding the least number which is power of 2. Finding the least number which is power of 2 and that is not present in our given array. That is not present in the given array. We can return that. Let's see how. With this first example, with this first example, 1, 2, 2. The least number that is not present in the array and which is also the power of 2 is 4, and 4 is our answer. Let's take the another example from the problem. We can see that we have 0, 6, 2, 1, 6, 4, 8, 10. The least number that is not present in the array and that is the power of 2 is, let's see, 0 is there, 1 is there, and 2 is there, 4 is there, 8 is there. Now 16 is missing, and you can see 16 is our answer. So by observing this pattern, we can find the least number which is power of 2 and not present in our array. This will be my answer only. How can I do that easily? See, first of all, I will find the size of the array. After that, I will have declared an unordered map of int comma int to store the frequency of every element present in the array. And similar thing I have done here. I'm storing the frequency of elements of array in my map. After that, I want to find the least power of 2 that is not present in the array, and what is the least power, 2 raised to the power 0, that is 1, using the value. And I'm saying that if it is not present in my map, the answer should be my value, and stop the loop, break out of the loop. After that, at each time, multiply value with 2 to find the next power of 2. 1, then 2, then 4, then 8, then 16. After completion of this loop, return my answer. So try to run it. Okay, sample test case is passed, and now submit it. This is how our second problem is successfully done. Tell me in the comment box what is your opinion to this approach. So let's jump to our third wonderful problem, that is minimum removal operation. Let's see what the description of the problem statement says. You are given an array of positive integer ARR, okay, and an integer k. So I have two things, array and an integer k. Let's see what we need to do. In one operation, we can take the largest value L present in the array. Keep this in mind. I have to take the largest element from that array. And what I can do, I can remove all the elements that are greater than L by 2. See, if the element is if the element is suppose 50, so what I need to do, 50 by 2, 50 by 2, that is 25. Delete all the elements that are greater than 25. I need to delete all the elements that are greater than 25 from our array. This is one operation. Okay. Initially, you are allowed to remove at most k elements, and k is given from the array without performing any operation. Okay, so we have a privilege in that, so that I can remove at most k elements without any operation. This is my privilege. At most k element means either 0, either 1, either 2 till k, at most k, not more than k. Okay. So from array without any operation, now what I need to find is I need to find the minimum number of operations required to make the array empty. I want to make the array empty, and what is the minimum number of operations? And in one operation, what can I do? I can select largest value. Don't forget that what value to be selected? Largest value. And then what elements can be removed? All the elements that are greater than L by 2, that greatest element by 2. Okay, let's see what can be the approach to this problem. At every element, I guess I have two choices. At every element, see, at every index, for every index, I guess I have two choices. Either to skip it means remove it because I have at most k privileges. So skip it if possible, because if my skipped elements are equals to k, then I cannot skip it. So I'm writing here if possible. I can skip that if possible, because if the skipped element are less than k, then I can do that. Then I can do that. Okay. But what is the second thing? I can perform one operation. I can perform one operation. Perform operation here. So I have two choices for every index. Either I can skip it or I can perform operations. What do you think? Which concept should I use here? Yes, it is dynamic programming. Can I use dynamic programming here to see which element to skip? Because from the n elements, I have to remove at most k. So which k element should be removed can be determined with the help of dynamic programming approach. And for the index that I am applying operation that can be detected by dynamic programming. See, what's the case? Which k element should I remove? And who will solve this problem? Surprisingly, dynamic programming. Let's see how this approach is going to work. Let's take this example 3347 and try to solve. My array given is 3, 3, 4, 7, and my k is 1. See, for performing every operation, I need to find the largest value. So here, eventually the array is sorted, but do you think here we need sorting? Do you think here we need DP plus sorting? Because I need, for every operation, I need the largest element. Instead of finding the largest element in every operation, what can I do? I can do the sorting of the array initially, and then the largest element will be present at the last index always. So, okay, DP plus sorting. Let's see for 3347 and k is equals to 1, how I can do that. See, this is my indexes, index number 0, index number 1, index number 2, and index number 3. What can I do? Initially, I can remove my largest element, that is 7. So for index number 3, for index number 3, let's see, for index number 3, if I am skipping it, I will jump to index number 2. I will jump to index number 2. Or I can perform operation here. I can perform operation here. Operation, I am writing operation. If I'm performing operation, let's see what will happen. I am adding one operation. I am adding one operation. And let's see, I have to delete, see, delete all the elements greater than what? 7 by 2. 7 by 2. That is 3 greater than 3. Let me write here greater than 3. So if I will remove all the elements greater than 3, that is 4, 7, I will jump to index number 1. I will jump to index number 1. I am writing indexes in the circular braces. So if the elements greater than 3 has been deleted from the array 4 and 7, that means I am at index number 1. Okay, let's use this same concept at every index. At index number 2, let's skip, but let's see here the value of k, the value of k is 1 means I can skip only one element. I have skipped element number 3 here. I cannot perform here skip operation. I cannot perform skip operation because I have already skipped one element, and maximum allowed skip element is 1 here. You can see k is equals to 1. So what can I do? I can perform operation. If I am performing operation, one operation will be added, and let's see to which index I will jump. The element and index number 2 is 4. So I have to delete, I have to delete all the elements that are greater than 4 by 2, that is equals to greater than 2, greater than 2. And you can see that all the elements greater than 2 are at 0, 1, 2. So can I say I am at index number -1 because all the elements have been deleted from the array, and now array has been deleted. Array has been empty. Array is empty. If array is empty, if index is -1, what I will return? 0. 1 plus 0 is 1. And from the skip, I can empty the array in one operation. Let's see with the operation. I have added one operation and now I am at index number 1. I have again two choices, either to skip it, either to skip that. Don't forget to see that I want minimum operation only. I want minimum operation. See, if I will explore this path, try to see if either 1 has been added already. If this will become either, if this will give 0 or this will give 1 or any value greater than 1, it will always be greater than or equals to 1. It will always be greater than equals to 1 because this can give 0, this can give 1, and 1 will be added to here. Always the minimum answer this can give is 1. This will give 1. Can you see that? Yes, because after performing the operation, this will give either 0 or greater value than 0. So that is how our answer is 1 here. Let's try to code this. How we will code this? See, first of all, what are the parameters? What are the parameters for this function? Let's assume our recursive function is solve function. And what are the parameters? See, I have an array, and before that, sort that array. I'm writing here sort that array, sort arr.begin and arr.end, comma. I'm sorting that array. Don't forget that. After that, I'm starting with the last index. So here it is index, and what is in the index? What is the value of index? I'm writing here. Please see r size -1, the last valid index. And I am here putting the deleted values and the value k. Initially, initially the k is given value. And how many elements has been deleted initially? 0. So the deleted elements are 0. Okay. After that, I will have a DP array. Let's discuss about this DP array later. And what is the return type of this function is my integer value. Let's see what I'm doing. Using this IND index, this is IND index. How to think about the base condition? See, if I am out of bound and initially my index is n-1, how can I go out of bound? If I am, if my index value is less than 0. Yes, if my index value is less than 0, then I am out of bound and I want to return my function with value 0. Agree? After that, I will discuss about the DP array. Later, let's see what two function call I can make. Either I can skip that element, but how I am how I am allowed to skip. Let's see how I am allowed to skip. If my deleted values, if the count of deleted values is less than k, can I skip? Yes, I can skip. So let's take an answer variable here. Let's take the answer variable. And because I want to find the minimum value, that's why I'm storing here the maximum value, that is int max. Int max. Now, if I'm deleting, let's see, if I'm deleting, answer is equals to, can I say minimum of answer comma delete means skipping. How can I skip? I can call this solve function again. Please be with me to see how I'm skipping array. If I'm skipping, let's move to next index. And what is the next index? Index minus 1. Index minus 1. If I'm deleting or skipping one element, do I need to add one with deleted variable? Yes. Yes, because I am skipping one element. After that, k will remain same and my dp array will remain same. Again, I am telling I will discuss about the dp array later. After that, let's see what is the second operation. Sir, my second operation in the comments operation is to delete all the elements, all the elements greater than this. I'm writing ARR of index by 2 greater than index by 2. First of all, I have to do this. After that, I have to make function call. Now, can we understand this part separately? Let me tell you. Let me tell you with the help of an example. If I have an array, let's take this array 10, 20, 30, 40, 50. Okay, let's think. Let's think how I am doing writing the index number 0, index number 1, index number 2, index number 3, index number 4. If my largest value here L is 50 and I want to delete all the elements greater than L by 2, that is greater than 25. What I can do, please see. I want to delete all the values means I want to delete 30, I want to delete 40, I want to delete 50. So means my valid array is now index number 0 and index number 1. Means I want to call this function using index number 1. Agree? I'm repeating. If I want to delete all the elements greater than 25 means 30, 40, 50 has been deleted. What is my left array? The remaining array is 10, 20 means index number 1 is valid now. Let's see how I can do that. There is a upper bound function. There is a upper bound function in C++. Using that, I will tell the parameters, don't worry. Using that, I can find the valid element from which it is deleted. Let me tell you, upper bound gives the smallest element that is less than or equals to that element. See here, I am passing an element x. So it will give the smallest element that is less than or equals to x. Less than equals to x. So let's try to think. It will give the smallest element that is less than equals to x, that is 25. 25. Sorry, x is 25. So it will give, it will give, it will point at the element which is less than equals to 25. That means it will point at the 20. And if I want to find the index number of 20, how can I do that? I will decrease, I will decrease means subtract arr dot begin and again -1 also, -1 also to find the index, to find the index. See, if I'm not writing it, suppose -1, it will give the count of the elements. And after that, I can do that. I will tell you, see, this was my function. How I can do that? I want to find the index. Let's write int I equals to upper bound function, and what it will do, it will take ARR of begin, ARR of end, and the third parameter is, let's see, ARR of index divided by 2, because I want to find the upper bound of that value only, na? ARR of index divided by 2 minus ARR dot begin to get the count of values, to get the count of values. And to find the valid index, I can minus 1 here also, or I can do this in function call. Let's see. Now, now I want to find the next answer, that is answer is equals to minimum of, because I want the minimum, don't forget that. Answer comma. See, I am performing one operation, so I can add 1 to my solve function. I can say to my operation add 1. What is my operation? What is my function call now? ARR. Now this is my I minus 1. This is not index minus 1. Please see, I is the count of elements that are remaining in the array, and what is the valid index? That is I minus 1. That is why I am writing here I minus 1, and my deleted elements are same because I am not deleting that. K is same and my DP array is same. After that, answer will be filled with the minimum value of answer comma this function call plus 1. I can easily return, I can easily return my answer. I can easily return my answer here. I guess this makes sense to you. Now only step remaining is to apply the DP here. And now talking about the DP, what's the DP array? There are two changing index, two changing parameters, that is index, it is decreasing, and delete, that is increasing. So I need a 2D array. So I need a 2D array. Let me declare the 2D array. How? My 2D array will look like vector, vector of int. This is my DP array. Let me tell you, it is index, and the second is deleted. So let's think, what is the range of index from 0 to n minus 1? That means the size should be n. And for the deleted, it is 0 to k. 0 to k. So what is the range? It is the range 0 to k. So what is the size? This is k plus 1. To generate k index, I need k plus 1 size array. Please try to understand. Now I will declare n comma vector of int, that is k plus 1, and initially what I will fill? Minus 1. This is my DP array which should be passed in my function. Okay, let's apply move. This is passed. Before jumping to this code, after the base condition, can I check if it is already solved? How? If my DP of index and deleted is not equals to minus 1 means it is already solved. Not equals to minus 1 means it is already solved. I can return directly DP of index and deleted. Okay, makes sense. After that, I need to store the value also. Can I can I rewrite this statement? Can I rewrite this statement? Return after, let me select the eraser. See what I want to store answer to my DP of index and deleted before returning it. Can I write using the red pen? Let's write this changes with the red pen. DP of index and deleted should be stored with answer and then it must be returned. This is my complete function. Now let me show you solution here. I have done the same thing that I have explained. First of all, sort this array before making any function call. Okay, declared the DP array with n comma k plus 1 initially filled with minus 1. Let's call this solve function with array. Initially the value index is n minus 1, the deleted is 0 and k and dp. After that, jumping to this solve function, I am with the index less than 0 return 0. Let's check if the if the dp, if this step is already solved or not. Now my answer variable is filled with int max. After that, if I can skip that element, how can I check that? If deleted is less than k, I can skip that and the call for the skip is explained already. After that, I can I can find the upper bound of that index which are already deleted and make the function call with I minus 1. I have already explained. After that, store this result and return it. Let's see. Okay, all the test cases passed. So we have successfully completed the questions. Thank you for joining this video and we will meet in the next coding contest. Thank you guys.